Hello and welcome to another session in this IBDP MAIHLSL course. And today we are going to talk about this SL 5.6, which says we have to find the critical numbers, or you can say the values of x for which the gradient of the curve is zero or undefined. So we will use our GDC to solve the equations where we have f dash x equals to 0, and we'll see what is the meaning of that and how can we use those for finding the local maxima or local minima points. Okay, so the main thing is we have first derivative test and second derivative tests for finding the local maxima and local minima as well, but here we will use the first derivative test in the MAISL course, and in the MAIHL part we will learn how to use the second derivative test also. Let me tell you something. Let's say we have the equation of a curve given by y is equal to fx as this. And it starts from this point. There is an end. Okay. This value of x is, let's say, a here. And at this point, you see the value of x is b. Here, the value of x is c. And the end point, which is end here, is the d. Now, in this curve, if you observe carefully, B is a point where we have a local maxima. Local means it is maximum value in its neighborhood only. That's why we call it local maxima. If you observe carefully, you can see the value of the function at this D point. Or I can say here we have f of D is the maximum value of this function from the interval a to d, right? But here x belongs from a to d. At d we are getting the absolute maxima. So this value in this case is the absolute maxima. Okay, you can have any number of local maximas or any number of local minimas, right? But the absolute maxima will be the maximum value of the function either in that given interval or this one. So here b is what? At b we have f of b, which is our local maxima, because this value is maximum in its neighborhood. Similarly for c, the value of function will be f of c, which is the local minima, as well as in this part that's also the local or absolute as well, right? You can compare it with other values. Here we have the absolute minima and absolute maxima, both same. So yes, it is also possible, right? So whenever they says find the local maximas, you can simply put f prime equal to 0 and check whichever is the local maxima or local minima or point of inflection sometimes. Okay, because at these local maxima or local minima point, you can see slope of tangent line will be equal to 0. And we know f prime of x gives the slope of tangent line at that point, and if we put it equal to 0, we can get those values where we can have a local maxima or local minima or the point of inflection that I will tell you in the next slide. Okay, so I hope you got the meaning of local maxima, local minima, and absolute maxima and absolute minima thing. Okay, now with the help of the graph, which we can draw number line for, let's say, a to b. Okay, you know, if we have a function f of x, y is equal to f of x, we can find the y prime is equal to f prime x, and we can check the sign of f prime in the negative infinity to a, whether it is positive or negative. If it is positive, the function is increasing in that. If it is negative, the function is decreasing in that region, right? Which we have seen already in the previous sessions. Okay, so now let's talk about finding the local maxima and local minima using the first derivative test. Okay, so for that, let's look at this chart. See, when you draw the sign diagram for f prime x, okay, then for those values which are less than a or neighborhood of a, right, which are left to it, if they gives you positive sign of f prime and negative sign of f prime for just more than that, in that case, the x equals to a point will be a local maxima. Now I'll explain it with the help of graph. See, graph was increasing first, then after reaching this a, it starts to decrease. It means that x equal to a must be the point of local maxima. Similarly, if you have this type of situation where graph was decreasing first, then starts to increase after a, it means x equal to a will be the point of local minima. But if it is not changing its sign, it was positive earlier, then again positive, means keeps increasing but changes the concavity, or it was decreasing first, then again it is decreasing. So again here concavity is changed, but nature is same, right? So in those cases we call x equal to a as the stationary inflection point or horizontal inflection point. Okay, so graph was increasing, again increased after that, but f prime is 0 in that case. Okay, in all these three we have f prime of a equals to 0. So this x equal to a is our critical number. Okay, so we will use this concept to check whether we are getting a local maxima or local minima at the critical points. If this is absolute value, then we have to find the value of the function at end points also. That I will explain in the last question of this video. Okay. So here is the question. It says the tangents at A, B, and C are horizontal. So we have 3 points A, B, C where if you draw the tangent line, they are parallel to x-axis. Here, here, as well as here. Now, first says classify the points A, B, and C. So what can you say about point A, B, and C? Here at A, B, and C, slope of tangent line is 0. F prime of x equals to 0 at these points. Say x equals A here. Okay, or I can simply say at A, B, and C. A, B, and C. And as you can see, at A I am having local maxima, at B point local min no, at B it is local maxima, at C it is point of inflection, and at A it is local minima, right? So we have maxima, inflection, and minimal. But remember, it is not absolute, it is local maxima and local minima here. Okay, so now we classified points A, B, and C. Second is draw a sign diagram for the slope of function f prime x for all values of x here. Okay, so for that, first I need this is my points are what? This point is -2 for the values of x. -2, then at C it is 0 and at A it is 3. Okay, so for the B part, the sign of f prime will be as follows. From this part to this part, it is increasing in nature. It means the function is increasing, so sign must be positive. So this in this region it is positive. After this, it starts to decrease from B to C and again C to A. It is decreasing. It means we can say we have negative as well as negative here. Now, after 3, it again starts to increase. So it is positive in this region, right? So that's how we can draw the graph for the sign of f prime, which tells us that at -2, it is changing from increasing to decreasing to local, uh, at this point B, it is local maxima here at this. It is point of inflection here and from negative to positive going up, right? So it is point of local minima in that case. Next is, it says state the interval in which y equal to fx is increasing or decreasing. So simply by using the same b part, we can say it is increasing when x belongs from negative infinity to -2 union 3 to infinity. And it is decreasing in the interval when x belongs from what? This -2 to 3. At 0, I will reject this. It is not strictly decreasing for that. Okay. So if you want, you can reject that 0 point. Otherwise, it's just a point. So if you even include it, that will not affect your answer. Okay. So in this way you can write the answer. Now D part says, that was the C. Now the D part says, draw the sign diagram for f of x. For the f of x, we can draw the sign diagram as follows. See, in the this graph is for f of x only, right? The given graph is for f of x. So what we can do, from this point to this point, it is below the x-axis. So for that part, -4 less than that, it is negative. And from -4 to 0, it is positive. So the next point will be this. For that, actually, you can also put f of x equals to 0 to get your numbers, which you have to write on this number line here. So 0 is the next one and other one is 5. So it is negative, and from -4 to 0, it is positive natured, positive. Then 0 to 5, for this region it is negative because it is below the x-axis here, and then after 5 it is positive. So that's the sign diagram for f of x. Now E part says comment on the difference between the sign diagrams found above. Actually, in the B part, for the sign diagram of f prime, it shows us that whether the function is increasing or decreasing, or have the local maxima or minima, or the point of inflection, right? But for the D part in the sign diagram for f of x, it gives us the uh, region in which the value of the fx was positive or negative, but nothing about local maxima or minima. It only tells us where the what are the points where graph cuts the x-axis, or it is above the x-axis or below the x-axis. Okay, that information you can make from here. Next one says a graph has a equation y is equal to 2x cube minus ax squared plus 3. Find in terms of a the coordinates of the point where the gradient of the curve is 0. Okay, so we have the y value as 2x cubed minus ax squared plus 3. It says find the x coordinate of the points where the gradient is 0. So first let's find the y prime, which is the gradient. So using the derivative formulas, can I write it 6x squared, right? The derivative of x to the power n is n x to the power n minus 1, or I can say ax to the power n has the derivative a n x raised to the power n minus 1. Okay. Now for this part, a is a constant number, so I can also say 2ax. So that's the y prime. Now it says in terms of a only, find those values of x where this y prime is 0. So put y prime equal to 0 and let's calculate the values of x from here. So 6x squared negative 2ax equals 0. Take out x common, or you can take out 2x common, gives 3x minus a equals 0. That gives me x equals 0 and x equals a by 3. And these are the critical points for us. Okay. Next part. Next question says you have to find fx is given to us and we have to find the value of f prime x and put that f prime x equal to 0 and get the values of x from there. So for this part, let's find f prime x first. So for the f prime x, we need to rewrite the given expression in the standard form, which is 2 times x to the negative 1 plus x raised to the power 1 by 2. So f prime x is, using the derivative rules, we can say negative 2x to the negative 2 plus half of x to the negative half. Now put this thing is equal to 0 as mentioned in the question. Okay, you can use the graph also to do this. Okay, so if you draw the graph of this expression, how can you find those points where f dash x equal to 0? It's simple. Use your GDC, draw the graph of negative 2x raised to the negative 2 plus half x raised to the power negative half, and find those points where the graph cuts the x-axis. That's your answer, simply. Right? draw graph and find x-intercepts of this f prime x. That gives you those values where f prime x equals to 0. Okay, in this way you can do this, right? Simple. Draw the graph. I'm leaving this question for you. Try this question by yourself. Draw the graph of this function and in the comment box tell me what are the values of x that you are getting where the graph cuts the x-axis. Okay, next. It says find the greatest and least value, not the local maxima or local minima. It says maximum or minimum value of this function x cube minus 6x squared plus 5 on the interval -2 to 5. It means both -2 and 5 are also included in that. Okay, so for that, what is the approach actually? First of all, I will calculate the critical numbers. I have the value of y, which is x cubed minus 6x squared plus 5. First, I will calculate the y prime. What is that? Using the rules of differentiation, 3x squared minus 12x. Now I will substitute this equals to 0. So put y prime equal to 0 for the critical numbers. We will get 3x squared minus 12x equals to 0. Take x common or 3x common. We get x minus 4 equals to 0. So from here I am getting 0 and 4 are the critical numbers. It means there is a possibility that I can get a maxima or minima or point of inflection at these 0 or 4. But I also have to calculate the values at other points as well. Okay, they want us to find the absolute maxima or absolute minima. So we don't need local maxima or local minima. So in this case, simply calculate f of 0, f of 4 and values at the endpoint, which is f of -2 and f of 5. Okay, so for the f of 0, let's find the value. You can use your GDC to get your answer. Okay, so f of 0 comes out as 5 simply. Similarly, f of 4. F of 4 is coming out as -27. F of -2, it is also -27. And the value of f of 5 also needs to be calculated. So for that, mm, uh, for that, simply put x equals to 5 in the expression. So I will get, put x equals to 5, that gives me 125 minus 150 plus 5. Okay, that comes out as 20 negative here. So now from this thing you can see that the absolute value of the absolute maxima is occurring at this point, right? And absolute minima is occurring at this point, these two. So yes, it's okay. You can, sorry, minima. You can simply write that you are getting minima at x equals to 4 and -2 and the minimum value is -27. Okay, and the maxima is obtained at x equals to 0 and the value is 5. That's the answer. Okay, so now quick recap what we did so far. Use the expression for finding dy upon dx equals to 0. Yes, we did this to get the critical numbers. Use the technology to sketch the graph of f prime and solve f prime x equals to 0. Yes, that was homework question as well. Find the f prime, plot the graph of f prime on the GDC, find those points where it cuts the x-axis. That's your answer. Locating the local maxima and local minima on the graph using the first derivative test and also finding the greatest or least value, not the local value, absolute maxima or absolute minima at the endpoints of the domain as well. Okay, so that's it for today and I hope you got all these things. See you in the next part. Keep watching, keep learning.